the stonework of the ancients. The main techniques were, number one, direct bedrock carving to create structures, and they were using machines with technology to scoop out the rock, and that technology used vibration. Then there were the massive megalithic block cutting and building techniques that were using real natural stone, and it also used vibration technology. So this is the same technology for slicing rock, same technology for cutting shafts, but some of them were different machines. Number three was megalithic polygonal block construction, and this was using artificial stone. Number four is also a form of polygonal construction, but this is using stone softening techniques. But this technique was only used when we couldn't do it one of the easier ways, because it required a large amount of a type of sap from a particular tree and some white powder which came from bird droppings. Number five were prefabricated blocks. These were just for temporary locations. So these were blocks that could be easily taken somewhere, put together in various designs, and when we no longer need it to be there, then they could be taken apart and taken away. And since we had the ability to easily carry these heavy items, it was quite a useful form of building. And I must point out that the examples of types of locations that I will give are not necessarily sites I believe are of Tantal, but if there are any that I think were of Tantal origin, like Petra, I will indicate as such. So, preferences and purposes for a site. There was a very strong preference for building in places that are inaccessible. Examples of the types of places are, number one, basins that are nestled between mountains or inaccessible valleys. The next type of location are the ones that are on top of inaccessible rock formations like mesas and buttes or even islands. So examples of this are Aleppo Citadel. Another location, as an example, is, I'm not sure if I can say this right, Fahada Butte. And another one, Baidicheng, which is an island. The third type of location is mountains. Mountains are either already flat top or can be flat topped. Or should I say just topped, like Machu Picchu or maybe Table Mountain. The higher and less accessible, the better. So Machu Picchu is definitely one of the ones that I feel that the ancients had a hand in. Anyway, the fourth is bedrock areas which are next to fresh water, like Giza, which, as you already know, I think the ancients have had a hand in, and Lake Titicaca, which also I believe that the ancients have had a hand in. The next type of location are the hard rock locations that are suitable for carving out whole buildings or carving buildings into caves, or like Petra or the Ellora caves or the Ajanta caves or even Lalibela or the Kailasa temple. Okay, let's quickly talk about what isn't the work of the ancients. Right, any kind of brickwork, not the ancients. Any small cut rock blocks, definitely not the ancients. Any badly fitted blocks, definitely not the ancients, unless it's inside a larger construction project and used as fill. Then there's the massive blocks that are not cleanly cut. They're not the ancients, but they could be using partial knowledge from a previous time, like Stonehenge. Another thing is obelisks. If you see obelisks that are ridiculously large, made completely in stone and of a hard stone, all one piece, that was the ancients. Others may have carved into them at some later time, or should I say scratched into them, but the actual obelisk is likely to be from the ancients. Same with the giant statues or the giant boxes. If they're high on Mohs scale, they're likely to be of the ancients. In terms of things like inscriptions, if it isn't obvious when you see the kind of inscriptions on them, they probably weren't the ancients. So if the people making the inscriptions had trouble making the inscriptions, they really did not make the actual statue. So if inscriptions are scratched in, they are not the original manufacturer, let's say. Okay, so back to building projects. The first of the great building projects was Tantal, obviously, Atlantis. Its location was chosen because it already had naturally suitable terrain, and the buildings were block construction. The blocks were megalithic in size, and only the most beautiful white, red, or black blocks were used. They were mainly white. As for the sites for the university, they would be chosen not just as being a good location for the university, but also if the rock is suitable for direct carving. So examples of this are Thebe and Neb, which are 100% just buildings cut out of the bedrock, thing that you see in Petra. So that's a good example of the way it was done. Other sites where it's cut into the rock are those that are sunk to ground level. And the reason for this technique is because it's easier to fill the area and then cover it up than to put plants over it, and no one would ever know it had ever been there. The university called Peosa, which is the Institute of Water, was built this way. So it was sunk into the ground. So now onto the subject of why the permanent versus the temporary locations. So obviously all the institutes, plus Tantal itself, were permanent, whereas the temporary locations were for things like the animal retreats, the places, the holiday places where people would go in order to meet animals. Like, I wanted a cat. That's one of my other episodes, by the way. I'd go to a cat retreat and I'd spend a lot of time there until a cat chose me. Anyway, that was one of the temporary locations. The other temporary location was for the watchers, and that was obviously temporary as well, because quite often a watcher location would be moved. It would be taken away and put somewhere else. And there were plenty of both of the animal retreats and the watcher locations, and they were all around the world, mainly in the temperate zone, but they were still in all kinds of places. So the preparatory techniques for the permanent and the temporary were essentially the same. Before any building was done, a site would be assessed for stability. It would then be flattened. Sometimes this was a relatively small job, whereas other times it was done on a massive scale. For example, the removal of the top of a mountain or the flattening of a plateau. So a small job would be one where there is a natural rock, like I'm going to use the example of Uluru because it's in Australia and everybody knows it. So that would have been the sort of place the ancients would have loved. But they would have flattened the top, and then they'd have built a temporary facility on the top of it. So these places are called mesas, or I think butes, and they were the ones that the ancients really liked because of their strength. They tended to be of harder rock because any soft rock that was around them had already been eroded by whether it's water or sand or wind or whatever. So most of the work was already done by nature. So preparing these sorts of sites was great, and they were really hard to access. So an example of one that I believe is of tantale origin is Aleppo. Anyway, a bigger job would be a large plateau or taking the top of a mountain, as I said, and the machines for this sort of thing were enormous. After preparing the site to be flat, a plan would be laid out and then indentations cut into the rock for seating the key blocks. This is not so obvious on the permanent sites because there are big blocks sitting in the indentations, but where a location was used and then the blocks removed, the resultant indentations in the flattened base are very obvious. It should be easy to find old abandoned sites based on this alone. But there won't be any remains of any kind there. The ancients were very thorough about cleaning up after themselves. If there are any sites where blocks or temporary blocks exist, so these are the prefabricated ones, that basically means that some disaster struck before the blocks or the buildings the blocks were made up of, that the buildings were made up of, were dismantled. So the only example I can think of in terms of this is Pumapunku. Have I said that right? It's pretty clear. They've got the prefabricated blocks that I remember, and they're just strewn around. They would normally have been taken away. So it must have been something terrible happened. We're going to look at the specific building techniques. First of all, we're going to look at the polygonal block construction techniques. So here we go. Polygonal block construction was one of the easiest and strongest ways for building things. It was very good in areas with a tendency for earthquakes. Once the area to be built on was prepared, the ancients had a choice of several ways of actually building on the site. But I will describe the typical approach for the polygonal masonry. So often we would start with some random, very large boulders, shape them a little for the right look and to ensure the sides would be a goodish fit next to each other. So imagining them lying in a straight line for where we wanted them to go onto the already pre-prepared ground. So as we put the first boulder in place, it would become the starter for how we had put the others in place. So if you have a look at the example that I've used in the picture, you'll see that I've coloured in blue the boulder that would be the one that would tend to start with. So I just chose this site because it had a lot of really good examples of what I want to talk about. So once we've got the first boulder in the right place, and it's a nice big solid starting point, then we can prepare the next boulder. And once we get that one ready to put it into place, we would use a softening agent on one side of the second boulder. And once it had softened the area sufficiently, then the second boulder would be put in place and pushed hard against the first boulder. Any seepage from between the boulders would then have to be scraped out. To ensure the boulders do not stick, so a membrane was used to make it easier, but if no membrane was available, then the boulders may simply be parted while the wet one dries, and then once dry, it would be put back in place. This process would be done again and again until the base level was completed. So it was basically using genuine natural blocks, softened on one side, and just added to the base. So added to, then added to, and then added to. Okay, until there was the full bottom level completed. Now, I've mentioned a couple of things already, which I have to come back and touch on. So if you want a description of what the membranes look like and how they were made, and the other thing that I want to go back to is the point that I made about when the stone softening was used. They pushed the stones together, and sometimes some of the softened area would protrude out. So basically it would squish out between the blocks. So they didn't want that there. So while it was still soft, they would use a ruler, kind of like a ruler, or something that they could scrape that part of the rock away. And this can be quite clearly seen in many places. So we've talked about the ground level and how it is essentially using natural rock. But as I mentioned before, there are other methods that it could equally have been done using the manufactured rock. Anyway, the next levels going up were usually a combination of natural rock and manufactured rock, with the manufactured rock being made of the same components as the natural because they came from the same source materials. So what to call the manufactured rock? Well, I'm not a geologist, so I may use incorrect terms. I tried to look up the correct terms and I came up with the term geopolymer or concrete. So if I'm wrong about what to call it, please let me know in the comments below. So just to make it easier for me to describe, let's just assume that the next layer will be the manufactured rock. But in reality, it was probably a mixture of natural and manufactured. Okay, so from there we would use the pre-ground rock mix. There were agents added to it, but I can't tell you what they were because I simply don't know. Anyway, it ended up being much like concrete, but it didn't need mixing, not like concrete needs mixing. So we had these membranes and they looked like rubber balloons, and we used those to hold the mixture in place. And once we'd put the mixture in, water was added, and we also used flat boards to achieve a desired shape if necessary, and the whole block might be artificial, or it might be a combination of the wet mix with some dry rocks, which could be put in to fill out the centre part. That made it quite a lot quicker and less effort. But there was a downside. It was not as strong, and so it was very, very important to ensure that the fill, the rocks, the dry rocks that went in, did not touch any of the sides, including the bottom of the artificial block, because that weakened it even more. So in order to make sure that the rocks inside the new block didn't weaken the structure, that is by touching any of the sides or the bottom, then slats of wood would be temporarily inserted into the newly forming block creation in order to keep the internal rocks away from the sides. So once the block was sufficiently dry to retain its general shape, the membrane would be cut just at where it was necessary, where the wood was, and the wooden slats would be pulled out. Because they were removed before the block had fully dried out too much, the mix had the opportunity to be backfilled into the area. Sometimes this left nubs sticking out where the residual wet mix had come out of the area, and sometimes it left like a hole, an area going inwards. So sometimes you see bits sticking out, and sometimes you see areas where it's sticking inwards. The mixture had to be perfect. Too dry and it crumbled over time, and too wet meant it wouldn't solidify, and we had to drain the blocks by once again cutting into the membrane. This doesn't happen very often, but it may have occurred more frequently by people who were not good at getting the mix just right. So that would be when they're using a technique at a later time maybe, and they were working using residual knowledge that they had. So I'm just guessing on that front. So based on what I've just been telling you, there were two ways that a block might end up with some strange nubs sticking out of it. Sometimes they might be removed or flattened before they became fully dry, and other times they were just left as is. There was another technique that involved stone softening, but it wasn't used very often in my dream regressions. But once again, that means that there's more than one way of doing it, and hence I explained the preferred way first. So now I will address the alternative way, which is, in my opinion, quite a bit more effort. So the boulders would be roughly shaped to plan as per the first process that I described, but instead of switching to the manufactured blocks as you work your way up from the base level, all the sides were softened and then placed. The softening agent I can tell you more about because I do remember about this in more detail. It was a special solution of a tree sap and bird droppings. So this was, as I said, a lot more work in several respects. So it required a lot more of the softening agent, and this was a time-consuming process to prepare it. It required every side of a newly placed boulder to be softened. So they were, one side was softened, it was placed tightly against the starter block, then it had to be removed, dried, and then the next side of that same block had to be softened, placed, made sure it was pushed tightly, removed, then dried, and then the next side. So it was very time consuming, and it was much more tricky if the blocks were very large. Another aspect to how much work it was is that the areas between the boulders where the solution was on the boulder for softening, it would get soft and allow it to be pushed against the previous block to achieve a very tight fit. But this, as I mentioned earlier, sometimes resulted in an ugly looking squishy bit at the joints. So this area had to be flattened. It looked a lot nicer than the squishy stuff sticking out, but more importantly, it enabled the masons to check that the seal was sufficiently tight between the blocks. If they left the squishy there, they couldn't see if they'd actually made a tight seal or not. So that, in a nutshell, is the polygonal building process. I'm going to talk about the more standardized blocks that look like they've been cut, or in fact have been cut. So very large blocks, and usually cube or rectangular sized. These are the ones that we're going to look at. So block sizes were planned out in detail so that the exact block might be cut. I'll come back to the planning phase a bit later, and I'll just step into the quarry right now. With two techniques for quarrying the rock that was being cut to size. So large chunks were removed from a quarry by drilling strategic holes, filling the holes with an expanding substance, and when done correctly, a large piece could be removed. Then this could be cut to size. Alternatively, a machine was used to scoop out the rock around up the part of the ground that was required to be taken out, and this was commonly used for when an obelisk or a statue was required, so that the exact dimensions could be just removed from the bedrock. And this technique is a bit more wasteful, but it is necessary when it came to doing the obelisks and the statues, but not so much necessary when it came to just getting blocks for building purposes. Once quarried, the natural stone blocks were cut to size using the machines. And yes, these are the machines that are going to come soon. I'm going to explain them to you, I do promise. But right now, we've got to come back to the planning stage. I just touched on it earlier, but now I've got to get down to the nitty-gritty because this is really the important bit. So planning is the key. So at first, a three-dimensional plan was drawn up so that non-conventional shapes within the structure could be catered for. So weight distribution and stress being an important part of the consideration when putting together this plan. Hence, there are non-conforming sizes of blocks. So let's pretend we are planning a pyramid structure. We establish what we want it for and therefore what components, rooms, shafts, accessways, etc. would be required. Next, we plan these components as if they are standalone. So we plan them as if they're able to cope all on their own with weight distribution of the roof and any specific changes in building materials and relative strength are included in the plan. Then we add into the plan any security aspects, like sealing off a particular area or waterproofing another area or making part of it airtight. These are all possible aspects required of parts of the building. Then the resonance factors would be taken into account if resonance or vibration figures into the operation of the building, which it often did. Again, looking at modelling the design in terms of stress and testing with these standalone models. For example, what would happen in an earthquake. The next part of the plan involves putting the standalone component parts together in the plan and seeing if they affect each other or if they can be compatible in a way that it doesn't prevent any of the components from doing what it's supposed to do. So once that, basically a juggling act, is done, and once again go through the modelling of the stress testing, etc., then we can look at how we put together the structure around it. Now, the structure around it, it's for protection and it's for weight distribution, so that it basically protects the component parts within the building. It provides an ability to ensure that there's no additional stress on those components, and it also provides a buffeting area. So, for example, for the resonance or if there was electricity distribution and those sorts of things, or any kind of pressure. So it basically is designed around those factors. Protective parts, obviously, are planned around the functional aspects, and one has to calculate the size of the outer structure that's required to sufficiently protect the planned components. And then looking at any aspects of the functional part that will go through the protective part. Let's say it's things like shafts or accessways, that sort of thing. At this point, we will have a plan that shows the exact dimensions of every block that makes up the structure, including the type of stone it needs to be. So looking at this plan that we've just created on a level-by-level basis, you would see that some of the blocks required need absolute precision, and other blocks can be cut rough, and yet other areas of the plan may only require fill. And then, of course, you've got to decide whether or not they're all going to be cut blocks, or if some of those blocks are going to be manufactured. Either way, the plan will specify that, and more importantly, it will specify the order in which the blocks are laid. So we're now at the point on our imaginary pyramid building project that we have a detailed plan and a stack of raw materials. So what's the next step? Well, that's to make sure that we have a good foundation. You've got to have a nice level bedrock base or a very good foundation, a solid block foundation. And of course, as I also mentioned, indentations which give extra strength to the blocks so they've got a nice place to sit in. So once the blocks are cut and transported to the location for construction, the next problem is how to ensure a tight fit. Assuming the blocks are cut to the right size or approximately the right size, then fitting them together should be straightforward. But the ancients wanted the fit between blocks to be incredibly tight. So they needed for each block to go through a very specific process with each of the blocks that they were going to be placed next to. The concept is similar to what we did with the polygonal, but this time it's vibration that is used instead. As each block is placed, they used a machine to create a vibration at a certain frequency which would stimulate the areas they were touching to essentially get the blocks to sand each other down until they were a perfect fit. And we are ready to start cutting the blocks and putting them into the right place according to the plan. So the stone cutting machine wasn't particularly big. Think of a tape measure, a regular, normal, modern-day tape measure, and imagine another tape measure at the other side of it. So you've got two tape measures with the tape in between the retractable parts of each end of the tape measure. It's kind of hard to describe it, but trying to put it into the context of something modern, that's about the closest thing I can find. The tape between the retractable components was not curved, by the way. So now I'm going to try to draw the actual machine. So we've got the two ends that retract and the tape, the flat tape in the middle. The things that look like spools hold the tape into place. And you can just pull it to resize it, make it bigger, make it smaller until it's the right size for the block that you're wanting to cut. So the next thing we need is a rod. And you can see lots of different types of rods in the pictures in Egypt. But these rods had holes in them, like they were measuring rods. So we need two of these rods, one for each side of the device. I apologize for the quality of my diagrams, but hopefully I'm getting the message across. So each of the rods go in one end of the device. So you'll see the arrows pointing downwards where the rods would be placed. And now you can see the rods in place. And of course this would be placed exactly on the block where the cut is required. Now all we need to do is tell the device to start cutting. Do you remember in a previous episode I mentioned the strange watch kind of devices that look like flowers? Well, these were used also for controlling devices. I couldn't find any graphics suitable, so using just a general graphic with a general kind of watch face, but it basically gives you the idea of how the items were controlled. So the device would be activated using the watch, which meant that it would start to vibrate. The vibration was at a frequency that would allow the rock to be sliced as if it was a piece of butter and the device was a hot knife. So at the end of all this, you've got two pieces of rock now instead of one piece of rock. So all you have to do is remove the device and move on to the next one. If you want to get fancy and complicated in what you're cutting, let's say you want to cut an L block. The rods had the ability to pin the device so that it would stop at a certain point on both sides.
enabling a block to be cut down to a certain point, turned over, and then cut again to that certain point, and a part of the stone then removed, creating an L block. Pin that was inserted into the rods to essentially make sure both sides cut to exactly the same level looked a little bit like an ankh without any arms. But since I couldn't find any graphics of ankhs without arms, I just used an ankh graphic, so you'll just have to imagine that it didn't have the arm sticking out of it. So when it gets slotted into the rod, it just sits there and it stops the device from going any further. As an aside, has anyone noticed the hats of the ancient Egyptians? Some of them have a weird-looking proboscis thing sticking out of them. So I've put a couple of pictures that I could find up. And the proboscis, it looks as if it's part of the mechanism of the device. It's almost like the ancient Egyptians found a broken one of these devices and used a part of it because it was maybe recognized as being from the ancients and used it as one of their hats. So now let's move on to levitation. You see pictures of these devices in many museums that have got Egyptian artifacts. I just went to the Met Museum because the pictures that you can get there are public domain, and I couldn't find any pictures of this sort of thing on the app that I'm using. I'm using Canva for most of my graphics. So those weird cylinder-looking things that the statues are holding are what are called rods of Horus. They're also called the wands of Horus, which makes them sound a lot more magical. And also they are called healing wands. I can't tell you what we called them because I can't actually remember. I'm so sorry about that. By the look of the statues, I would say that the ancient Egyptians considered them symbols of power. By that I mean regal power, so that a pharaoh would have one of these because a pharaoh is important. In some of the statues, you see them holding one in one hand, as in the picture that you can see now, or you see them holding two. In the picture that I found, which is now showing, one of the people in the statue is holding another device that looks exactly like what I was talking about earlier with regards to the clips that would go inside the rods to hold the mechanism to a certain point before cutting. Some of these rods on the statues look flat-topped and others looked kind of sausage-shaped. But I assure you they are all the same device. If you've listened to my other episodes, then you may remember an episode on flying and the technology around that. So the rods that go around the waist for flight are basically the same technology. So let's get back to block levitation, shall we? So we'll start with these wands. So they actually open up in much the same way that the rods that we saw for the cutting actually work as well. So these items look like they're just one rod, but when they are opened up, they are essentially two rods with paper-thin, very flexible alloy, I think it is. It's kind of metal, but it's bendable and soft between them, scrolled very tightly. You can pull them open and you will have this very thin paper-like wafer, let's call it a wafer, that you can place underneath the stones for levitation. Ideally, you'd have 2 of these for a block. You could possibly do it with 1, if the other end was a wheelbarrow, I guess, but no, let's just assume 2 of them. The technology has a few complications. The parts of the case which the wafer scrolls up into and lives in, they can sit on the end of each end of the wafer. They give the communication in terms of activating and deactivating the actual wafer. But once activated, they are not necessary to continue with the use of the wafer. So you can actually remove one or both ends. But the problem with that is that it'll just keep doing what you actually asked it to do before you removed the ends, because you have no way of telling it now to go up higher, go down lower. All you have is it levitating to a certain position. And that can be fine in certain circumstances, but that's not always what you want. I almost forgot to mention how we achieved the forward momentum. It's really very, very easy. You just push it. So all it took was somebody walking behind the block. Like, I'm just taking my pet rock for a nice walk. One of the Egyptians had some of that wafer. They didn't have either of the rods that the wafer attaches to, and they certainly didn't have the watch device that was used to control it. But they'd managed to work out how to make the wafer jump. So it was really amazing. They got 2 of these wafers underneath a block, and they managed to find that, I don't know how, must have been trial and error. They'd managed to find the right frequency. So they whacked the block really hard with what looked like a tuning fork. It made a ringing sound anyway, and the block just lifted. They pushed the block, and after about a few meters, it just came back down onto the ground. And so they just whacked it again, and it lifted, and they just pushed it forward a little bit, and then it came down onto the ground. And then they whacked it again, and it was very entertaining. They were smart enough to work out that they couldn't whack it while it was still in the air, or it would just go higher and then be out of their control. I guess that's the problem with residual technology. But let's start with the 3 massive monster machines used for cutting, drilling, tunneling, and carving stone and bedrock. The machines were created by Uran, who was the first leader, and he used them to carve out the canals and the tunnels and the buildings, etc., of Tantal, or Atlantis. So the one I'm going to concentrate on is called Ogier. And this machine can scoop and carve at a speed and accuracy which is absolutely fabulous. So what does this machine look like? Well, let's start with the fact that it starts off looking like a box, just a regular, everyday, massive box of 2 stories high and almost as wide, metallic, and, well, it doesn't bounce up and down at all. No, it's more like just a metal box, but a really, really, really big metal box. So now in the picture, we've got approximately the right person to monster dimensions, relative dimension, I should say. And you can see that it's a big metal box. So as I mentioned before, it starts off at about 2 stories high. Now I say starts off because as the things that do the work come out of it, it kind of gets taller and wider, and yeah, so it's when it's active, it's bigger. In my dream regressions, I'm operating one of these beauties from
relatively nearby, not too close, but not too far away. I can see everything it's doing quite clearly. And I'm giving it instructions using a flat screen. Now, this looks a little bit like an iPad, but it's like one piece of smoky white crystal. And I do wonder sometimes if some of the things from the real world kind of seep into my dream world, because it's just uncomfortably like an iPad. Not that I use an iPad, I just use my iPhone, but this device, it's just got that same feel about it as an iPad. Once it starts working, the first thing that happens is the top opens up and what looks like a round ball on a stalk comes out. It kind of looks like a cross between a head and an eyeball. And then another one comes out, and another one, and another one, and another one, and there's just heaps of these round things on stalks, and they can move around quite freely. They can go up, they can go sideways, they can fan out. So it gives the machine a wide range of viewing and measuring capability. The next thing to pop out of the machine looks like an arm with an ice cream scoop on the end of it. And then another one will pop out, and another one, and another one. Now, clearly my diagrams are lacking because the ice cream scoop should be attached to the machine. So they should be appearing out of the machine, but my diagram doesn't show that. But when we rectify that by showing the various scoops attached to the machine, suddenly it looks very cluttered. So I thought I'd show you the arms and the scoops before I attached them. So what we've got is a mechanical arm with ice cream scoop hands, but all these different hands are a different size. So they're ranging from massive ice cream scoops down to tiny, weeny little ones. So let's talk about why I call them, or I say that they look like ice cream scoops. It's not only because they look like ice cream scoops, but also because they work like ice cream scoops as well. So when they're actually operating, it seriously looks like an ice cream scoop going through ice cream. And that's because the technology is using a form of vibrational frequency, which as it touches the rock, it makes it so that the machine can just go through it. And yeah, I just can't quite describe it. So it looks like there's a heap of these ice cream scoops, and they're all sizes, as I said, and they come out of the body of the machine as they are required. So they start scooping large scoops to get the shape right, and then small scoops, and then there's the flat-looking tools as well, used for creating and making a surface really flat. But it really is just a series of tiny little scoops that are so small that their scooping is too small to see. And the smaller the scoop, the greater the detail of the carving, and the smoother the results. Just as an aside, I imagine that if the ancient Egyptians stumbled across one of these things, they would just think it was a very large metal block. And they would probably put some inscriptions on it and dedicate it to some god or some pharaoh. And yeah, that's what I think. Anyway, that's just an aside. So now I'm going to show you some pictures of places where I think that these machines could have been used because they have the right look about them. So I'm going to take you first to the unfinished obelisk in Egypt.
I'm sure you all know the size of these great big pieces of stone. And it's not just Egypt that's got things like this. Let's move on to Baalbek in Lebanon. There's some amazing sized things there that you just cannot begin to imagine them creating using copper chisels and hitting things with another rock. But the picture that you're looking at now is the ceiling of one of the caves, or one of the buildings, I should say, in Petra. This is a close-up, well, relatively close, and you can see the handiwork of this type of machine that I've been talking about. Now let's move to some ceilings in some other caves. These ones are in India, I think, and it's just the sort of thing that these machines would be carving out. I can't say if this was done by one of these wonderful machines, but it's just the sort of thing that the machine would in fact do. I'm showing you these ones from India with the intricate designs on them because of how complex it is to carve such a thing in rock, in solid rock. So remember, these pictures that I'm showing you now are of caves, real caves. I could just keep going for ages, finding examples from around the world. So the first step was to use a series of lasers, or at least I think they were lasers, to measure out the specifics of the area to be carved. And I bet you've already guessed what part of the machine was doing that, those head-like eyeball things. So they would work out the exact specifics of the area, and you're able to use that as a kind of baseline on which to do your design. Inbuilt into the machine is actually the levitation principle, so that it can be raised up and actually moved easily from where you've had it in storage to where you're actually going to be doing the work. So you've got your baseline. So what you have to do is use that with the crystal tablet to actually do your design. But anyway, the end result is you come up with a design, and that's on your crystal tablet. And when you come to do your actual work, and basically you could just leave it to it. But that didn't tend to be the case. People stayed with the machine as it was doing all this. As the vibration touched the rock, it somehow managed to powder it. I can't quite describe, but the machine had incorporated into that scooping little arm thing a suction, and it would pull into the machine the leftover rock, and most of the bits of debris just went straight into the machine. There was very little dust that was left over. Around the back of the machine would come a reconstructed block, and the block that came out was dependent on what the settings were that you asked it to manufacture. And then at the back of the machine, awaiting, were pallets for these blocks to drop onto. This time we're looking at tunneling, shafts, tube drilling, and a few other little things that I couldn't quite sneak into the other episodes. So tunneling. This isn't too different to the previous episode, except one of the monster machines has much larger scoops. So this is the machine called Cotier. So it's the one that is specifically designed for tunneling, and it's so much better at the whole process, whether it be horizontal tunneling or tunneling on a gentle incline, But remember, these were really, really big machines. So coming back to these ice cream scoops, well, this was really scooping on a massive scale. The scoops operated using a frequency vibration that as the scoop touched the rock, it turned to powder. So there were handheld devices that worked in the same way using vibratory frequency principles. Okay, so let's move on to shafts now. In many ancient sites where there are shafts, the original building that sat over the top of them is long gone, and so all there is left is this big hole in the ground. Shaft cutting was a bit different to all the things that we've talked about before, because these were just square or rectangular shapes that went straight down. And what was required to achieve this was a metal square. And it wasn't very big or very complicated. In fact, it just looked like a frame. Most of the frame was about 2 to 3 inches high. So this picture that I'm showing you now is about the best representation of what it looked like, but without the legs. So it was just a frame. One of the amazing things is this frame could just be folded up and put into a box. It was surprisingly lightweight, and it could be resized. You could make it into whatever size square you wanted, and then you would just lay it on the ground. It would basically start to vibrate and would just slowly sink into the ground. So it would just kept vibrating at the right frequency that it's basically sliced through the rock that it was sitting on. And the controls we had made it possible to be very exact as to where it stopped, so that it would vibrate down to a certain level and then just stop. We were able to then pull out the metal frame and start on the next stage. So essentially, this metal vibrating frame was really like a cookie cutter, because it cut into the rock as if it was dough making a cookie or a biscuit. So once we'd removed the cookie cutter, then we needed to be able to remove the actual core. And for that, we placed a similar sort of device. It was a ring, and this ring just looked like a bangle, a regular bangle. And it did its vibrational frequency thing to the same level as the shaft. And then we were able to just snap the core, the round core, the small round core, snap it out by just levering it quite easily about. It would snap off at the bottom and we would pull it out. So at this point, what we have is a shaft cut to the desired depth, but the rock is still in there. It's just an outline of a shaft. And we have a tube drill size hole also to the length of the shaft with the actual tube removed. So it's hollow. That small part in the very center of the shaft is hollow. So at this point, we can send in some of the standalone ice cream scoop devices on a long arm so they can be lowered down into the hollowed out tube area, and at the bottom they can carve out the base based on the directions we give it. I don't know why this is important, but when halfway through the scooping, we would pull out the ice cream scoop devices and we would put in some small cubes, very strong weight-bearing cubes, into the half of the shaft that had been scooped out. The ice cream scoop devices are then sent back in to finish off the scooping on the other side of the shaft. Sometimes at this point, the block seems to be leaning ever so slightly to one side. But anyway, the scooping device is finally removed and replaced with what looks like a 3 or sometimes a 4-pronged harpoon. The device goes into the core hole and the prongs flatten out against the cut floor. So this is the device which, when activated, levitates the block out of the shaft. The end result is now a fully formed, very neat shaft and a large block with a tube hole cut all the way through it. Some of these blocks were quite useful actually, especially in areas that needed a conduit. I think it might be obvious to everyone how a single column of rock is created. The massive blocks needed for the statues were cut out from the bedrock using the scooping machines. They were scooped all 4 sides, and then once that was done, the scooping machine went under the block until there was just a small neck of rock remaining at each end. Then 2 support blocks were put in at each end. The rock that was left attached to the bedrock was then removed. So essentially, this giant piece of stone is then just sitting on 2 supporting blocks. It was then easy to just put in the 2 levitating scroll rods and lift out the block. The block would then be taken to the location where the carving would take place. And that's where the carving machines, which generally were smaller versions of the machines that we've already described, would be given the design for what was to be carved and pretty much left to it until the point where the polishing would take place. It's really strange to see documents or hieroglyphs of statues being moved by the dynastic Egyptians, and that's because they didn't carve them and then move them. They found them and moved them. And you can see one of the people pouring down oil, I think it is, in order to make it easy for these statues to be moved on a sled. And isn't it amazing that they would actually not move the whole block and then carve it if they had the technology to carve it? Because it's risking the statue way more by moving it once carved than moving the block and then carving it. I mean, just imagine going to all that work, carving a statue, and then you start moving it and something happens and all that work has been for nothing. Isn't it much better just to move your block? And, if your block chips a corner off, well, you can work around it when you're doing your carving. But you can't really do anything about it if you're moving a statue. So the statue moving, that is utter nonsense. And it's just so totally illogical. So let's talk about polishing now. Whether it's a large one piece of stone sarcophagus or whether it's a beautifully carved statue of a person sitting or standing or whatever, if it has a high level of polish, then a fair chance is that the technique I'm going to describe next has been used on it. How would we get a really nice surface today? Well, I guess, let's say a piece of rock. We might grind it till it's nice and flat, and then we might sand it or use some kind of tool to just smooth it out a bit. But then what would we do? we've got a nice flat even surface, we'd polish it, or even like use some kind of polish on it. Using the tools that we've got today and the diamond sandpaper and stuff like that, it's still quite a lot of work, but it was quite different, the approach. A substance was applied to it. Now this substance was slightly yellowish, and the nearest thing I can describe it to is honey. It looked very much like honey. So the substance could be just poured on. So like if you were dealing with a straight, flat object, that's pretty easy. You just pour it on. But once the vibration was applied, it didn't really take very long, maybe 5 minutes, for the substance to do its job, and the surface was amazingly smooth. So all that was left over at that point was just some very, very fine dust. And it would be beautifully polished, but wherever there was a difference, like if we had a slightly incorrect gradient on one surface, it would just be a very beautifully polished incorrect gradient. Polishing was done not just because it looked nice, which obviously it did, but also it was believed that by polishing a stone item, it limited the amount of erosion that would occur on it. I'm not sure how true that was, though.